This is a talk on real-time web apps and PHP. I'm assuming everyone's a PHP developer, or does some PHP, right? Cool. What inspired me to give this talk was that I've worked with real-time technology for quite a while, and I often see Stack Overflow and people asking a question about how do I build real-time chat with PHP, or how do I do real-time notifications with PHP, and somebody clever comes in and says use Socket.io, and obviously Socket.io is a node solution and there are ports to the languages. So I want to prove why there are options for PHP. It might be the right option, it might not, and then I'll look at other options where you're still using PHP but other frameworks too. I work for a company called Nexmo. So we're an API that lets you send and receive SMS messages, make and receive phone calls. So if you phone that number and you got a response, that actually went via the cloud, then via my machine to send a response to you. Two-factor authentication, and a bunch of other stuff around telephony. We've got loads of connections with carrier networks, provision phone numbers, and so on. Basically a cloud communication platform, which is why I joined them, because I'm interested in real-time and communication. So here's what we're going to cover. We're going to cover why real-time. It's obviously something that's quite important. You know, why should you even care about this real-time thing? And then what are your options? So 6 factors to consider. And then 3 solutions for PHP, kind of architectural setups and so on. So I've got 15 minutes for this talk part, and then 15 minutes to demo, so I better be quick. If I talk too fast, please do let me know. So why real time? Here's Twitter. There's a little notification that's appeared, and there's a menu bar. Right? We all know what that means, right? We know that there's a new direct message for us, or there's a new set of tweets for us, and we're seeing that user interface pattern or user experience pattern across not just social networks, but across any kind of application. So my mum and dad will see these things in apps and realize that they need to click on them to see the new data that's available. So it's expected, this experience is expected. These like UI patterns are very much expected. So whether it's notifications or whether it's activity streams that are not only in social, but also in news, in sports, in trending live events, we see this everywhere. Data visualizations is a great use for real time. I haven't got a GIF here, unfortunately. But to see those stats change in real time gives an idea of what's happened right now and then what is happening as the data changes. And we see the changes in the graphs, and it's a great way for us identifying trends and so on. And the same with the idea with the activity streams previously is that we've seen what has happened and what is happening right now. Who uses some sort of chat application? I'm not going on until everyone puts their hand up. Go on. Who uses a chat application? SMS, Slack, HipChat, everybody, right? Everybody. It's massive. It's not just chat between people now. It's chat between bots, as we've seen earlier as well. A lady called Mary Meeker does an internet trends report every year, and she identified that 6 of the top 10 most used applications globally are messaging applications. So whether it's Viber, Line, Facebook Messenger, Twitter, WeChat, and so on. So 6 of the top 10 most applications are chat applications powered by some sort of real-time technology. Uber's not here, right? It's in Milano. So you don't have Uber here. You've maybe got another app. But the point here is that across the world, Uber has revolutionized the taxi industry. Thinking wider than that, it's revolutionized the on-demand logistics industry. And part of that is the experience that you get within the application. You see where the taxi is when you've hailed it. As it comes towards you, you can communicate with the taxi driver, you can communicate with your friends, potentially jump out the application and send SMS to tell them your ETA. Again, the point here isn't really about real time, it's more about the experiences that it's enabling, and that this is expected now within applications. These applications have set the trends. Who uses Word and SharePoint? I used to use Word and SharePoint, right? It's quite a long workflow, right? You write a document, turn on track changes, check it in, someone checks it out, edits it, the next person then gets it, edits it. It's very, very long-winded. Or you send emails and people make multiple edits and you try and merge them. Whereas now we write a draft of a document, we put it in Google Docs or Office 365 Word, and then we share that link and we collaborate online instantly. That must save hours and hours and hours of time. And I think collaboration using real-time technology is something we're going to see increase. So IDEs embedded in all sorts of applications to share and collaborate. So whether it's social applications becoming far more social, things like Facebook, because of real-time notifications, activity streams, chat, whether it's chat itself, things like Slack, things like HipChat, proliferating across the whole world, and being a core way that we communicate, or whether it's productivity applications like Google Docs or Office 365, becoming much more productive because of real-time collaboration, or even things like Uber that have absolutely revolutionized a vertical. All these things offer this real-time experience. So if that real-time experience is expected in applications, not just geeks, nerds, techies, but general consumers of applications, they expect to see those real-time updates. They don't expect to pull to refresh. They don't have to refresh the page. But if that isn't there, then the application will feel broken. That's my idea anyway. That's what I think, and that's what I think we're seeing. So we need real-time functionality. How do we add that to our PHP applications? The things to consider are: use an existing solution. There are lots of solutions out there. No matter your language, there will be a solution of some sort available to you. And the reasons you should use an existing solution are because the connectivity for these things are still quite tricky. So WebSocket is touted as being the server-to-client best solution, but you still, for proxies and firewalls, need HTTP fallback. There are loads of kind of different ways of doing that across different devices and so on. So choose an existing solution and you get that out of the box. An existing solution should have support, community, maybe paid support, or at least from the open source community or a dedicated community forum. If it's used, hopefully it's maintained, especially if you're paying a license for it. But even if it's an open source project, you can get involved and be part of that maintenance. As more people use these frameworks, they identify common features, it can end up in that framework. So you get that for free, or you can contribute and add those yourself. Scaling, now I don't just mean use a hosted service because it scales, obviously that's one of the benefits of the cloud, but if you use an existing solution, somebody will have solved these problems and documented them. So you can scale if you choose a self-hosted solution because there are strategies in place for that. And there are lots of solutions in place. The majority of these, obviously except the company that I work in the middle, are more real-time messaging solutions. We're a hybrid of telephony plus messaging. So there's lots and lots to choose from. This goes back to the Stack Overflow thing around choosing a language that you're comfortable with. And no matter what language you are comfortable with, there is highly likely to be a solution for you. Now, PHP is tricky, and React PHP seems to be the base of all of these solutions because it's an evented I/O solution on top of which Ratchet is built, things like Dnode PHP, PHP daemon. But there are obviously solutions for other languages too. I've got a technology guide. I'll obviously share these slides afterwards, and Gabriella will send them around too, so you can have a look at that later. Are you building with mobile in mind? I'm sure everybody is, but not all these frameworks were built with mobile in mind. A lot of the focus of these frameworks were initially for web browsers. So, okay, you've got a web browser on your mobile, but what about native? So you need to think about the libraries that these frameworks offer and have a look at those. Are you looking for Windows, a Windows SDK? That's potentially tricky to come by. Do these frameworks think about the fact that they're interacting with mobile devices and that you're on a network, a mobile data network, where the user is being charged money for sending and receiving data? That's an important point. SSL is required because there are proxies that get in the way of connectivity. Actually here, there's a proxy if you connect to the hardwire, to the Cat5 cable, and it just totally messes with everything. So I couldn't even load a page earlier. Some solutions with mobile libraries, again, this is just for reference. This is something that I've come up with, and I'm interested in feedback. And the point here is it's about how the client and server communicate within your application. So I'm calling this communication patterns. As I said, it's about how the communication works between clients and server in your applications. And then different frameworks offer different communication patterns. The first one and the simplest is something I'm calling simple messaging, which is exactly what the WebSocket API offers. So we create a connection, we have an onMessage function, that we assign a function to this onMessage. Anytime a message is sent over the wire, this function is called, we do something with that data. Really, really simple. On the server, we have, in this case, I've got a library that has a connection. I get a socket, which is, it represents that connection to that individual client, and I can just send some arbitrary data over there. It might be a string, it might be binary. But this is the very, very simplest. And if you wanted to do anything more we need to add our own data to that payload, create our own protocols on top of that simple message passing. So a couple of talks ago in here, there was a mention of PubSub at AWS IoT. PubSub is great for, instead of just having a great big data payload, you subscribe to something, a topic, a channel, a subject, which identifies the data you're interested in. So it might be news, it might be sport, it might be entertainment. It's a great way of partitioning your data and identifying the data that this client is specifically interested in. This is something called Fay, which is available in, this is the JavaScript obviously, but it's available in Node and Ruby. It's just a simple example. So I'm subscribing to news. Anytime I get a new news message, this function is called. I can take any arbitrary data in that, but I know it's related to news. In this case, I'm taking the headline property off. And on the server, the library, the framework provides this ability to publish. So on/news with this data payload. Again, something else I've come up with is evented PubSub. So it takes this idea of PubSub, where you identify the data by subscribing to a channel. But then something that works very well in applications and data itself is you've identified the data you're interested in, but what's happening to that data? So if you think of a database or a row in a database, it can be, a new one can be created, an existing one can be updated, one can be deleted, it can be read. But one of the reasons I think Socket.io has been so successful is because it has that evented nature to it. And some people refer to the real-time web as the evented web. So here I've got a status, which is a namespace. This is using something in Socket.io called a namespace, but you can think of it as a channel or a subject. And this is my status updates. And then I can bind to different events. So if a new status event is created, this function is called. If one is updated, then this other function is called. If it's deleted, and so on. And then on the server, I can identify again with this io.of. That's the syntax that is in Socket.io. Okay, I'm going to be publishing stuff on the legacy status namespace, and then I can emit events from the server. And again, it could be, a new status is created, updated, deleted. These are just examples I'm giving because it maps very well to data manipulation, but you can think of it, you can make those events very arbitrary. Firebase, data synchronization. This is a really interesting one. This one tends to work, data synchronization tends to work quite well if you've got a data structure and you're manipulating that data structure in code and you want the framework to deal with synchronizing those changes across the wire into other clients. So in this case, I've got a reference. I can then bind to different events on that reference. So say it's a collection, I can bind to the child added event, and then I'm told anytime a new item's added to this collection. Child changed, obviously an existing one changed, removed, one's been removed, and I can push things on. There's a whole lot more to the Firebase API. I definitely recommend checking it out and having a look at it. And it's really powerful. And there isn't any server-side code, especially with Firebase, it's a hosted service. But even with open source solutions like Gun.js, the server-side code is very minimal because the point of the framework, again, is to receive data and send those changes to other connected clients. You're not writing business logic in there. You might add some stuff around security or dealing with operational transforms, collisions and data changes. RMI, I'm not going to go into this because I am kind of limited for time, but RMI, RPC is also another communication pattern. I'm just going to skip through this. This is Signal R. There's also something called dnode that's worth looking at. The point here is that you write an object on the server and it exposes those methods on the client. And you interact with an object on the client, it ends up calling the methods on the server, and vice versa. I'm happy to grab someone afterwards or later on and go through that. Here's all the different types, the 5 types. Here's where some of these examples might fit. Again, it's just for reference because I am short of time. And here's where some of these solutions might fit. I don't expect people to be capturing this. But again, hopefully these slides are a decent reference point. So the interesting thing, I hope, is around architectural considerations in 2 different scenarios. Firstly, you have an existing application and you want to add some real-time functionality to it. Or secondly, you're starting from scratch, you want to build a real-time PHP application. So the first one, if you've got self-hosted, and definitely something you see in the Node world, is that you see Express.js, which is a web server, and Socket.io used on the same HTTP server. So it's dealing with persistent WebSocket connections, but also HTTP request responses. There are pros and cons to that. It can potentially be easier to get started, but I think over time, the complexity of having all these different things within the same application code base can be quite tricky. And with PHP, I don't believe it's an option at the minute. I don't think you're going to have a Symfony or Laravel or Cake or CodeIgnite or Codebase and just start adding real-time persistent connection handling to it. There is React PHP, which seems to be the foundation for all these, Ratchet. PHP daemon looks quite interesting, but all the documentation's in Russian, which is a bit of a barrier to entry for me, even with Google Translate. And I actually reached out. I'm not an absolute expert in this space, so Chris Bowden, who's contributes to both React PHP and wrote Ratchet, socket2.me. I asked him about this and he said, yes, it's possible. So to have your React PHP and Symfony apps running within the same process, within the same server, but not common or probably recommended yet. There are some projects that are starting to do this by running the HTTP stack on React, but it's very uncommon at this point. So I wouldn't recommend it, and neither would Chris. Again, I'll share these slides. You can ping Chris, follow him. So the first true option, in my eyes, is to separate the web stack from the real-time stack. And it's nice to stick a message queue in there. It decouples your real-time and your standard web stack. And Redis is a great solution. And there are a bunch of other queuing in there. You could make HTTP requests back and forward, but I would say that that's not. It's not quite as fast. Queues will be a little bit faster. So let's have a look at a demo. So I'm going to use Symfony as my example here. Apparently 25% of the people that answered my tweet use Symfony. So I've got a chat controller. And I'll quickly show you the demo. I've got a side-by-side window. And I want to change that back to Ratchet. Oh yeah, so obviously I'm going to use Ratchet as my real-time server here. So I've got a post message action. So the UI, there's an AJAX request that's made from the UI. It sends a request down. I pull out the data, create a chat message, I persist it, and now I need to publish it. So I want to publish this data onto Redis. And I've cheated there, obviously. But I've created a data payload, and I'm going to go with this evented pub sub idea. So I've identified this event as being a new message type, and I'm saying the data payload is the message itself. I'm creating a JSON payload. I'm connecting to the Redis client. I'm creating a Redis client which connects to Redis, which is running, hopefully. Yeah, there we go. It's running. And then Redis supports PubSub, so I can publish a chat message which contains my payload, which has an event property on it. I'll execute this and show you without me saving that. So, is that connection fuse? Okay, that's a good sign because I haven't started my app. Okay. So we are connected here. Say hello. So it's submitted, but obviously we're not sending any real-time messages yet. It's not going onto that Redis queue and it's not reaching Ratchet yet to send it. But it has been saved, and when I refresh the page, we see it. So now if I save that, I'll show you the Ratchet code. So the bin, so the executable. Ratchet for me seems a little bit complex because of the evented IO nature of it and the threading system that's in place. But here I'm using Ratchet with an HTTP server, a WebSocket server, and you need to use this syntax. I create a factory, within there I pass an HTTP server, within that I pass in a WebSocket server, within there I pass a chat definition. Now the chat definition implements an interface that means the WebSocket server knows how to communicate with it. I'm creating a Redis client, I'm connecting to it, and then when it has connected, again, because of this evented IO loop, I couldn't work out exactly what was going on, but I found some examples and copied them and got it working. I'm sure if I read the docs properly, I would have worked it out properly. And I'm calling init and passing in my Redis reference. So within chat, we can see I implement this message component interface. And there's a bunch of stuff here. There's onOpen, and in onOpen, I get an incoming connection, so a socket, and then I'm keeping a reference of these connections, so the WebSocket connections. And there's a bunch of other stuff that I just ignore for the moment. But within init, where I pass in my Redis instance, I use, again, Redis PubSub. So I'm saying I'm interested in chat messages. When those occur, I get an event, and then I loop through my WebSocket clients, and I call send on them, passing the payload. So it's quite simple, really, once I've got around the I/O nature of Ratchet. So now, since that should be working, I'll refresh this just to be safe. Okay, so that isn't going out to the internet, that's just down on my machine. Ratchet's running locally on my machine. So that's quite simple, really. And as I said, I'll share the slides and the code, obviously. So the good thing here is that we've got this loosely coupled architecture. We've got Redis in the middle, or any queue. It's PHP both in the web stack and in the real-time stack. So you are writing PHP. I said the integration is relatively simple in terms of just these three components, the queue and the two stacks. Ratchet is standards compliant, so it's trying to be a WAMP, a WebSocket application messaging protocol. So anything that, if you search for Autobahn or Autobahn.js, all the libraries that work there in terms of clients, so like JavaScript, Android, iOS, will connect. The cons are that at the minute there isn't any HTTP fallback, so you can only connect over WebSocket. So if WebSocket isn't working for the network, then you're stuck. You need to write your own HTTP fallback or contribute to the open source project and add a really good solution there. The abstractions are pretty low. It is that simple messaging layer. It's just you send a big data blob and I need to add that event property to the messages. And I think the I/O nature of React versus the versus the way we write Symfony, Laravel apps, it's different. It's a different way of writing, so it's a different way of thinking. And it's self-hosted, so you need to scale. So the great thing about having this loosely coupled architecture is that we can go, well, I'm sticking with Symfony on my in my web stack, but I'm actually going to go with something like Fay, which has is available in Ruby or Node as my solution there. Gianluca, how long have I got? 10 minutes. Cool. Right. So I'll show this demo. Right, so I'll stop my. I've stopped my Ratchet process running. So the nice thing here is because I'm already publishing over Redis, I don't need to change my Symfony code at all. So in this Fay example, I've got an index.js. I've got Redis, I've got a Fay, I'm creating a server, I'm creating this Bayou node adapter. So Bayou protocol, it's a protocol for it was originally in like the Comet server land. Here I create a client. So the interesting thing with Fay is that on the server you have clients that allow you to publish and subscribe. I'm creating a new Redis client. I'm subscribing to the chat channel on this Redis on the Redis instance, and then I'm binding to messages. So I'm only subscribing to chat, so I know that any messages that come in are chat. And then I'm publishing fayclient.publish/channel. So in Fay you need to have a slash. It's kind of namespaced. So /chat in this case, and I'm parsing that JSON payload into an object and using Fay to pass that along. Let me look at the one thing I've remembered is I didn't show the client code. So the client code for the Ratchet example was just a WebSocket. So I'm connecting on open on message. The difference with the Fay one, I'm including the library. I'm subscribing to a /chat channel. I'm checking if the payload has an event on it, because I'm going, instead of just pub/sub, I'm going with evented pub/sub, and then I'm calling add message to the UI. So if I run that, go to the. So I'm just going to execute my Fay example. So that's running. I should have had some output there to tell me it is running. But if I change this to Fay, so there's different logging in here. I know it's connected over Fay. There's a whole bunch of stuff you can do with Fay. It's by a guy called James Coughlin, who's quite a clever fella. Okay, so now we're using Fay, and it's been quite easy to make that change and use that. Okay. So the pros and cons here. The pros is it's got PubSub built in, so it's quite a nice way of communicating. It's got connection fallback. It's actually got something called connection upgrade. It starts with polling and it moves up to WebSocket. It's got Redis queue support, not just in the PubSub mechanism, but also in terms of synchronizing state across multiple Fay instances. So you can have loads of different servers running that connect to the same Redis instance, and it deals with making sure those messages connect, go to all these different Fay instances. I think the integration with a PHP application is pretty simple. It's obviously not PHP, so you've moved away from using the same language across the way, and you need to scale. The next example is a hosted service. I used to work for a company called Pusher. Who's heard of Pusher? Okay, a few people. Cool. So the nice thing here is because I'm using a hosted service, I can integrate directly into my PHP app. And I don't need the message queue. I don't need another two components, so the message queue and the other real-time server. Okay, so let's have a look at that one. Oops. So to do this, I do need to remove this code. So all I'm doing here is I'm getting a Pusher instance. That there's a bundle, that there are packages or bundles for each framework. This one's a Loppy Pusher bundle, and I'm calling trigger. Because this is an evented PubSub solution, I'm saying here's the channel, chat, here's the event type, new message, and here's the message payload. And the library deals with the serialization. So if I look at the JavaScript's really nice. So I include the library at the top, I create a new connection, identify the application on the hosted service with that long app key. I subscribe to the chat channel, I bind to the new message event, and then I just call this function. Anytime that happens, the framework, the JavaScript just deals with that. I've got another one down here, but we'll get to that a bit later. And that's it. It's as simple as that. So if I go to my example. So that's pretty quick. That has gone out to the cloud and back, so the connectivity in here is pretty good. And I can just show the JavaScript, here we can see we've got Pusher debug messages in there. So really simple. So how long have we got? So 10 minutes. How long now? 5, cool. All right, so the nice thing about this as well, and the nice thing with cloud services, is that you can integrate lots of different things. So Nexmo obviously give you access to the telephony network. So a few of you phoned a number earlier. I'll not get anybody else to phone it. But if you want to turn, if you did phone that number, turn the sound up so we can hear an incoming text message, maybe. So down here, I'm going to also call so I've got this function here I'm calling send SMS to all. So not only am I going to be triggering a message via Pusher, I'm also going to be sending an SMS message using Nexmo that gives us access to the telephony network. And in here I'm going to get a list of numbers that have come in. I'm going to loop through those callers, and I'm just going to call sender, which is from this Nexmo package, send text message, the phone number of the person that called in earlier, the text from the message, and the username, which is me. I published that message. So I hope this works. Let me turn my phone on. Let's try that. So I think that's failed. Demo gods. Oh no, so it might have taken a while. Maybe there were quite a few numbers. There was a loop that was making an HTTP request, and they were holding on for a bit. But I haven't got a text message yet. Oh, I have. So who got a text message? Okay, just 2 people, 3, 4, 5, 6, a lot. Okay, quite a lot of people. So that's quite nice because then we've got an SMS and web integrated chat solution. And obviously you dialed in via voice, so we brought voice in there as well. So I think that's pretty cool. And obviously, if you're in like the AWS or you've been thinking about IoT, then these could be devices, they could be anything. One of our customers unlocks cars by sending a text message. You know, you'll buy the car, it's got a number on it, verifies that it's from you, and you can unlock a car, and away you go. So I do think these hosted services, and Pusher or PubNub or Firebase, they're all very simple and very powerful. They obviously scale for you, that's the point. They're managed and dedicated. You know, Nexmo focuses on telephony networks and dealing with carriers and buying and selling numbers. I've only just joined them. It sounds like a complete pain. I wouldn't want to do it. And Pusher and PubNub, they manage these, you know, WebSocket at scale and HTTP fallback and so on. And it is nice that you can directly focus on building your Symfony or Laravel application and write your code directly in there without needing to manage additional components. The con, as always, is that you're relying on a third-party service. So it's obviously buy versus build. And I do think that I'm sure you all do. This is quite a silly idea, but it's that you think about things like, you know, how much is it going to cost to run that service for a year? How many engineers to build it yourself? What's their salary? How many weeks to build it? And how many weeks to maintain it? And then do that with the buy versus build example. Again, I just thought it was quite a nice example there. So, how do you choose? Definitely use an existing solution unless you've got a very unique idea that you need to implement. And there are, you know, lower level frameworks you can even use then. Use languages you're comfortable with. Obviously with PHP you're a little bit restricted, but hopefully as more and more people use React PHP, as you know, PHP as a runtime improves, and it's massively improving, it might become more of a viable option to stick with that for all your real time. Rather than going, well, okay, well, I'm still going to build my Symfony application or a Laravel application, but I am going to have a real-time server in some other solution. Do you need to be mobile friendly? That's an obvious one to think about. And then think about these messaging patterns and which ones fit with the type of functionality you're building. Again, the reference slides that I've got earlier should kind of help with that. Those architectural considerations and the examples, I'll share all the code later, and then there's the consideration of build versus buy. I do believe that users and ourselves as users are expecting real-time functionality, and if it isn't there, people think their app's broken. There are lots of options. Please use this information to make the right choice for you. Please do follow me on Twitter. I'm at Legator, and drop me. I've got open DMs. Ask me any questions you have. I do hope this helps. There's lots more resources there. I guess we've got time for questions. I think I don't really know, to be honest.
Thank you. We have a question about mobile, because more mobile closes socket connection when app goes in background.
Yeah.
Would you recommend this type of technology of other solution to restore previous connection or something?
Yeah. So even with native, so yes, in the browser, the WebSocket connection, when it's in the background, eventually it will close. I don't know if there's certain timings on different devices, Android and iOS. Even if you have a native application, when it goes into the background, eventually it will close. Unless the application has been, like if you submit an iOS application to the App Store and flag it as being a communications type application, they will allow the resources to be run for even longer. But I would say on mobile, use this sort of technology for more engaging, interactive functionality, and notifications, use SMS or push notifications.
Thank you.
Okay, is that the question? Thank you.